Welcome friends, Igor is here, and in this video we will talk about surjective linear transformations. In this lesson we will define surjective linear transformations and learn how to check if a linear transformation is surjective. Let's get started. A linear transformation is surjective, or an alternative terminology is onto if it is surjective as a function. This means that every element of the codomain is equal to a value of a function on some input. In general, not all elements of the codomain are the values of the function. For example, if we look at the square function, which we can think of as a function from real numbers to real numbers, then -1 is not a value of the function. Therefore, this function is not surjective. But this will never happen with surjective functions. Every element of the codomain is a value of a surjective function. Here is an example of a linear transformation from C2 to C2. The vector 1, 1 cannot be represented as a value of this linear transformation. Therefore, this linear transformation is not surjective. Let's look at another example. Here we have a linear transformation from the polynomials of degree at most 3 into 2 by 2 matrices. This linear transformation is surjective, and let me explain how to show this. To prove that this linear transformation is surjective, we need to show that every element of the codomain, which is a 2 by 2 matrix, can be obtained as a value of this linear transformation on some input from the domain, which is a polynomial of degree at most 3. So, let's take an arbitrary vector in the codomain, which is a 2 by 2 matrix with some arbitrary components x, y, z, w, and we're looking for an input polynomial a plus bx plus cx squared plus dx cubed, so that the value of t on this polynomial is the given 2 by 2 matrix. Just to be clear, the 2 by 2 matrix with entries x, y, z, and w is arbitrary but fixed. It is the polynomial here that has unknown coefficients, and we're looking for the polynomial that makes this equation true. This equation is an equality of 2 by 2 matrices, and this means they must have identical entries. This gives us 4 equalities, which we can regard as a system of 4 linear equations in unknowns a, b, c, and d. To solve this linear system, we represent it in the matrix form, and, for example, we can find the reduced to row echelon form of the augmented matrix of this system. It turns out that the coefficient matrix is non-singular, so this linear system has a unique solution given by this equation. But this means that for any possible 2 by 2 matrix, we can find a polynomial of degree at most 3, so that the value of the linear transformation on this polynomial is the prescribed 2 by 2 matrix. Notice that the input polynomial of course depends on what output matrix we would like to receive. But because every matrix is a value of the linear transformation, it means that the linear transformation is surjective. If you found this video useful, please give it a like to help others discover this content, and subscribe to this channel to see more of these videos. In the next video in this series, we will talk about the range of a linear transformation. I will see you later.